Hello, this is Awab Akib, and today we're going to discuss October-November 2019's Paper 2 pre-release material. In the last video, I did Paper 2.2. You can already find that playlist in my channel, and today we're going to do the other variant 2.1. Okay, so this is much more simpler than the other papers, the other variants pre-release material. So in this, what you have to do is you have some types of slabs. Okay, they are given. So you have the Exeter, you have the London, and then you have several more, and you have their rate of square meter. So you are in the first task, you're going to ask the user to input the type, and then you are going to ask the user to input the total square meter that he or she needs. Okay, each type has a certain price. So in the first part, what you're expected to do is just calculate the price by multiplying the total square that the user wants, the total area, multiplied with the price of each type. Okay, this is only what you have to do in task 1. So you can see you have these types, you have the price per square meter. So it says store the type and price per square meter, prompt, and allow the user to input the length and width. Okay, so since we have the length and width, if you multiply them, you'll get the square meter square. Okay, and then you calculate and display the total number of square meters of stone slabs required, rounded up to the next whole meter. So what this means is, if you have a total square meters of area, let's say 4027.65, so this must be rounded to 4028 square meter or meter square. Okay, like this. It's very easy to do. If we do it in any programming language, we can simply use the mathematical function called ceiling. Okay, so what it does, it would round it off to the nearest number. But since we'll be writing pseudocode, so we'll see how to do that. Okay, now without further ado, let's start with task 1. So I've already written the Python code for this. I've already uploaded the link as well. So you have the types here, all the types that have been copied from the question. Okay, so Dover Exeter, I only did it for 3. Okay, and I set the price square to 0.0 initially. I asked the user to input the slab type, and if the type is valid, only then it checks. So if it is Dover, then the rate is $30, then otherwise 35, otherwise 42, exactly how it's written here. Okay, nothing different. Otherwise, I asked the user to enter an appropriate type. Again, I've only used 3, you have to use all the 6. Then I asked to enter the length, then width. And what I did is I took their multiplication, I took their product, and I found the total square area that is required. And I took the math ceiling. This is a built-in function in Python. So I simply went ahead and used that, and it does the same thing. It rounds it off to the nearest whole number. Okay, like we've been asked here. Okay, so next whole square meter. And to get the total cost, what we did is we simply multiplied the total square, whatever area we have, with the price. Okay, so let's say let me run this. So the user asks for London. The length is, let's say, 30 meters square or 30.5, and the width is 20.1. Okay, so if you multiply both of them together, it says this is the total square meter required, and this is the total price. How did we get the price? We multiplied 614 by the rate of London. Okay, which is simply $42 in our case. Okay, this is very easy and straightforward. One thing worth noticing here is that both of these have been rounded off to the nearest whole number. Okay, let's see the pseudocode now. So this is the pseudocode. So first of all, we declare the variables straight away. Okay, so we have the real, okay, so since we'll have the numbers in decimal, or we'll say the float or double values, whatever you want to call it, we'll declare them as real. Okay, this is what the question asks us. So the slab length is also 0, slab width and total cost is, they are all real. The total square is going to be integer. Why? Because we are going to round it off to the nearest number. Okay, so that's the purpose. We don't want any decimals in this case. And then we enter the slab type as string. Why? Because we'll be using a string, a set of characters. Then I went ahead and I asked the user to input the slab type. He or she did that. If it is Dover, then $30 of price per square meter. Yes, price per square meter, yes. Then Exeter, then London, and all of that. Okay, up to York. Again, these are simply copy pasted from here. Okay, I've done nothing else. Then if none of these options are inputted by the user, I simply ask or simply give the prompt that please enter an appropriate choice, and I end the case. Okay, so this is my case. So if you don't know how case works, we go to the first line. If the input here was here, let's say Dover, so this should be slab type. Okay, small mistake. So if the slab type the user entered is, let's say, New York, so you don't see New York here. Okay, so it would print this error. Otherwise, if somebody enters Portland, then the price of the slab would be set to $49.5. Okay, then we went ahead and we asked the user to input the length and the width. We are already asked for the known slab type, it's here. We entered the length and width, and what we did here is we took the ceiling like I mentioned before in this case. So this is your rounding off. Okay, now in the code here, how I did is, let me take a screenshot of this. Here is 100.25. okay, so I take the modulus by 1. So the percentage here means modulus. Okay, what modulus is basically the remainder of anything that you divide. So a modulus b simply means that the remainder of b, a, and whatever you do here, this remainder would be the modulus. Okay, so I first take the modulus by 1. So if you take a modulus of anything by 1, you get the part after the decimal. Okay, so I get this. So it returns me 25. Okay, sorry, 0.25. Now I'm checking that if it is greater than 0.5, I'll round it off, otherwise I won't. Okay, I'll just round it to the nearest number. So 100.25. okay, so we're here. What I do here is I subtract the remainder from the value. So I have 100.25 and I subtract the remainder, which was this is REM, and what do I get? I get the other part that is before the decimal with me. Okay, so now here I have 100 saved, and what I do here is I just add 1 and I get 101. So you can see we went from 1 sorry, this should be 75. okay, since the condition is greater than 0.5, so we go from 100.75 to 101. This is what rounding off is. Okay, now if the number is, let's say, 100.15, so we get the remainder. Okay, and we simply subtract the original number with the remainder, and what we get here is 0.15, which gives us 100. Okay, and in the final step, what I'm doing is I'm simply printing the total square meter that's required, and I'm just multiplying the cost of each slab multiplied by the total square meters that we have. Okay, in order to get the total area, and I'm printing the cost exactly like how I showed you in the Python program. Okay, so this is your task 1. Very easy and simple to understand as well. So I've already put the link of task 1, 2 and 3 pseudocode in the description. You can see it. Okay, it's fully working. I'll put the Python codes as well. Okay, now up to task 2. So let me finish task 1. Okay, task 2 is again pretty much similar to task 1, except there is a small difference. Now we have complex shapes. Patio is made up of a large number of rectangles. Okay, so now you want to select these stones individually. Okay, so this could be your Exeter, this could be your London, this could be your York. Okay, like this. So you have to tell the length and width of each one of them. Okay, so I have a rectangle, and if I have a patio of rectangular shape and I want it to be made of types of 3 slabs. Okay, so I'll have 1 and 2 and 3. Okay, so this could be your type 1, this could be type 2, this could be type 3. All of them would have different lengths and widths, or uniform, whatever suits you. So what you need to do in this question is basically calculate the individual prices and individual areas and then sum them together to get the total values. Okay, so you can see here, so enter the number of rectangles making up the patio, calculate the dimensions of each rectangle, that is basically your area, allow the dimensions to be entered. Okay, so you are going to get value for each one of them. Then you calculate the total area, again round it up to the next whole square meter, and then you calculate and display the total cost. Okay, so the code is just, you know, with minor differences, pretty much the same as of task 1. So now we have a new variable called rectangular count, because we'll be keeping a check of how many rectangles do we need, like I showed you here. So if the patio is to be made up of, you know, let's say 2 rectangles, or let's say 4 rectangles like this. Okay, so how many inputs do we need? So we need 4 times length and we need 4 times width. Okay, so that means we need to run a loop. You can use a for loop, you can use a while loop, and you have to run it for less than equal to the number of times of the rectangles in your question. Okay, so if the rectangles are 4, so this loop should run 1, 2, 3 and 4 times. That means you'll be getting a length and width inputted at every step. Okay, so and then I have a counter that will be used to maintain the while loop. Okay, and the total square and the slab type, which is again similar to the previous question. So I asked please input okay, the rectangle needed for patio. Okay, before we begin this, let's run the code and see how it is going to work. So I say I need 3 rectangles for my patio. For rectangle 1, the length is going to be 3.2 and width is going to be 2.5. Slab type would be London. Then I'll say 1 and 2, and slab type would be Exeter. And then I'll say 10 and 20, and the slab type would be, like, let's say York. Okay, sorry, we don't have York in our program. Again, this is just for demonstration purposes. So I'll use 10, 20 and London, and it finds me the area. Okay, so it tells me the total square meters and it tells me the total price that my patio would cost. Okay, and you can clearly see the loop has run 3 times and it is accurately checking for errors as well, as was the case in this code. So this is how it's going to work. Okay, I'll just explain the pseudocode, because if you understand pseudocode, you'll get the Python code as well. So I'm initially starting the counter from 1. Okay, so now the reason why I'm using counter as 1 is because here you can see that I'm printing that calculation for rectangle 1. Okay, like I showed you before. So if I have 3 rectangles, it automatically says rectangle 1, then it will say rectangle 2 and 3. So that's why I'm starting the counter from 1 to make, you know, the results more convenient for the user. And then I'll have to run it for rectangular count plus 1. Why? Because if we enter the rectangular count as 4, so our counter is running from 1, right? So if we start from, if our rectangles are going to be, let's say 3, okay, and if our counter is starting from 1, so if I say less than 3, this would run only 2 times. So I have to make sure that I add plus 1 so that the loop runs all the way to 3. Or you can also use the less than equal to sign. Okay, whatever suits you, no worries. And so this loop would run for as many times as you input the rectangle count. Okay, then you ask the individual length, individual width, and then you ask the slab type. Okay, and then you check, and then you take the ceiling and then just add. Simple enough. This is again the same thing, we've done this before. In this part I've directly used the ceiling function, which is again, you know, in standalone terms is not correct, but I've already shown you how to implement ceiling. Okay, so I'll just be using that here for demonstration. Now here I say that slab length is it multiplied by slab width, and I take a ceiling of that. Okay, again, so whatever the variable is, the decimal number is, I convert it into the closest whole number. Okay, and then I add the total square count. Now what does that mean here? So if I have 2 rectangles and I have 3 and 2 and London, then I have 4 and 5, and then I say Exeter. So this is what it is. So you have to sum the total meters of slab that are needed. Okay, so this should be this multiplied by this, L1 multiplied by W1 plus L2 multiplied by W2. Okay, and this is the sum. And similarly for the price, whatever your price get for the first rectangle, you have to add it to the price of the second rectangle. So for this purpose, I am going to rewrite the variable every time. So initially the total SQ is 0 and total cost is also 0, right? So here I'll get the dimension of the first square, and then I'll add the total square, which is initially 0. So we'll get whatever the dimension of the first square are. And then we took the ceiling, okay, to convert it to the nearest whole number, and then we added the previous total of the area. And similarly for the total cost, what we do is currently, if we say the price per square meter is 30 and the total square is for the current rectangle, let's say I selected 3 length and 2 width, so I multiply these two and then I add the previous cost. Okay, so let's say if I selected 10 rectangles, so at 9 rectangle I'll have the sum of rectangle 1 to 8 stored in this variable, okay, which would eventually be updating our total cost here as well. And then I simply increment the counter by 1. Why? So because we go from here all the way to up here. Okay, so this would ensure that the loop runs as many times as the count of our rectangles. All right, and this is just I'm printing an empty line, okay, for the sake of clarity. And at the end of the while loop, in fact outside the while loop, I simply print the area, the total square meters that are needed for the patio, and then the total cost of the patio that is needed. So this was our task 2. And finally for our task 3, it says that now you have to allow for the wastage percentage. Okay, now what this means is since you know the stones can easily break, so we'll account for them in our question as well. So you'll ask for the percentage wastage that you think would will not be usable by the stone. And once you enter that, you'll have to add that percentage to calculate the wastage and add this number to the square meters of the stone slabs. Okay, so what this is saying is you account for the percentage wastage and then you add that much amount in your slab. Okay, so you're ordering additional amount of stone slabs so you can replace the broken ones, and then you're going to find the revised cost and the revised area. So let's go to task 3. In the Python part, again there are not much changes, except here I have asked the user to input the wastage as a float value, or in our pseudocode this would be the real value, and everything else is the same except for these 2 lines. Okay, now what I'm doing here is, okay, so let me do this on the journal. So I have the wastage percentage multiplied by the total square, and then I'm adding the total square and I'm taking the ceiling. By the way, I divided it by 100. Okay, so let's say if I have a wastage of 10%, let's change, I have a wastage of 10%, okay, and if my square meters are, let's say, 2500, okay, so I want to account for the wastage. So what I'll do is I'll take the percentage and I'll add it to the original square meters. So what this means is, so this would be here, and this is 250 plus 2500, and if you add them together the answer would be 2750. So this means you will have to order 2750 square meters of the slabs. Okay, the total area would be this much, so that you can account for a 10% wastage. So basically, to be on the safe side, we're gonna have to order some additional number of slabs. So this is what this question is asking. Okay, and then you have to round them and then finally display the total area and the cost. Again, to do this, let's open the term task 3. Okay, if I run this, I need 2 rectangles and the wastage I'll use is, let's say, 15%. The length is 3, width is 2, London, and then I'll say the length is 5 and width is 9, and slab type is London again. And so this is giving me the revised square meters. Now if you multiply these, so 9 into 5 is 45, and 45 plus 6 would give you 51, right? But it says 59. Why? Because we asked for 15% of wastage inclusion. Okay, so essentially we are ordering additional slabs as per our calculations. Now based on this square area of slabs, we'll be having a revised price, so price would be more, right? So what I'm doing here is I'm simply multiplying the price of each price per square meter with the revised squares area. Okay, so this revised SQ is going to be multiplied by the price per square meter, and then I'll simply add the revised price, exactly how I'm constantly updating the price or the area here, like this. Okay, so again, if I have, let's say, 15 rectangles and they have a wastage of 15%, so this is basically finding the updated value by including the wastage percentage. Okay, so I use the ceiling here, and the incremented value of slabs will be multiplied by the price per square meter. You'll get these from the type of slabs you choose above, and then you simply add it to the revised price so that you can constantly update the variables. Okay, and then again you're adding +1 into the counter and you're incrementing it by 1. For the pseudocode, this is again the same thing. So instead we have the wastage here. I declared it as real, okay, because you will be entering a percentage, and percentage could be a real number. And then you have the revised squares area, and then you have the revised total square. Okay, so this is the only new thing, and here we are going to input the percentage, and it will be saved inside the wastage. Okay, so you can see it is real here, and we saw this while loop before. Then you have the case, it will select the slab type, and finally, so you're taking the ceiling here. Again, the ceiling was done in task 1. You find the area, you take the ceiling, that is your total square for that piece of rectangle. Okay, for the nth rectangle, let's say out of 10, if I am at rectangle 5, so this is holding the current area of the rectangle. And for the revised square area, what I'm doing is I'm just taking a ceiling and multiplying the total square area with the wastage. Okay, so again, like I said before, we are counting for the incremented number of slabs, and we're adding it to the previous total number of slabs, and we take the ceiling of this whole calculation. And for the revised price, again the same thing, you are going to multiply the revised square area multiplied by the price of any of the slabs, and we add it together to update the revised price overall for a whole program. And at the end of the while loop, I'm simply going to print the revised price and the revised square area. Okay, so this is how it is going to work for task 1, 2 and 3. So I have uploaded the task 1, 2 and 3 in the drive, and you can clearly see the pseudocodes are also given. Okay, so if you have any questions, kindly let me know. Otherwise, please do share these videos with your juniors, with your seniors, whosoever needs help with these. Thank you so much for watching.